13 on the homework.
Okay. So we have our graph, we have log base 2x, and I want to talk about the important aspects of graphing a logarithmic function. So recap, when you're graphing an exponential function, what was the most important thing you had to put down? Like if I gave you y is equal to 2 to the x minus 3 plus 4, what is the first thing you did when you had to graph that? Asymptote. Does everybody remember that? When you're graphing exponential functions, the most important thing is an asymptote, isn't it? Right? And then after the asymptote, what's next? The special point. Everybody remember that when we graphed? The way you graph exponential functions, everything hinges around, all right, there's this asymptote, there's a special point, right? And then you draw your little swoop, right? Sometimes you draw your swoop this way, sometimes you draw your swoop this way, sometimes your special point is below the asymptote. But everything hinges around the asymptote and the special point. Everybody okay with that? Right? And the reason I want to refresh your memory is that's exactly what's going to happen when we graph logarithmic functions. The way we graph a logarithmic function is it's kind of the same shape, right? And I don't know if you noticed this, but do you see how there's a vertical asymptote? Okay? So I've got a vertical asymptote, and I have a special point. All right, see? And that special point is 1 away. Right? There's ways where you can make the special point different distances. I'm not going to do that to you because that's actually really ugly. But right, for all practical purposes today, your special point's 1 away. Okay? Now, just for fun, somewhere scratch work, I just want to make sure we're getting used to drawing, make sure we know how to draw a logarithmic function. I don't want grid, I just want you practicing. So I want everyone to draw, at some random spot, I want you to draw a vertical asymptote. Okay. In fact, I don't want it on a grid. I just want you to draw a vertical dashed line. That's your vertical asymptote. And then I want you to put a dot off to the side, and that's your special point. So everybody got your asymptote? Everybody got the special point? Now we're going to graph. The way we're going to draw a logarithmic graph is we put our pencil on the asymptote, we hang with the asymptote, hit the special point, and then turn to the right. Everybody draw one. I'm not asking if it's perfect, right? Are we okay? Is everybody, first of all, do you see it's very similar to the way you draw a logarithmic graph is very similar to the way you draw an exponential graph? It all hinges on, okay, where's my asymptote? Where's my special point? Now I'm going to draw a swoop. Got it? All right, so now let's get down to graphing all this. What if I gave you y is equal to log base 2 of x minus 3? And I want to graph that. Well, first, if I want to graph that, what does the minus 3 do to the graph? Move to the right 3. The rules haven't changed, have they? Right? The rules are if it's inside the parentheses, it's going to move left and right. If it's outside, it moves up and down, right? And if it's inside the parentheses, it goes backwards, right? Is everybody okay with that? And so what the red graph is going to do is going to take this, the blue graph is going to take the red graph and it's going to shift it to the right 3. Right? Now, how do we go about graphing? Well, your priority is find the asymptote. The first thing we want to do is graph the asymptote. And one way you could look at this, you can say, well, okay, I'm going to take the asymptote. It started at 0. I'm going to move it to the right 3. And that works, right? But here's the way that always works. What you do is you take whatever's inside the parentheses and set that equal to 0. You see, if I take what's inside that parentheses and I say, okay, that's in my parentheses, so I'm going to set x minus 3, set that equal to 0. Does everybody see we get x equals 3? Well, that's convenient. X equals 3 is actually a vertical line. That is going to be your asymptote. So if x equals 3, there's your vertical line. So I get a vertical asymptote at x equals 3. Everybody okay with that? Where's our special point? is 1 away, hadn't moved. Does everybody see we got our asymptote, we got our special point? So if you've got your asymptote, you've got your special point, you can draw your picture. So we put our pencil on the asymptote, hang with the asymptote, hit the special point and curve to the right, and we're done.
How do you know where the special point is?
It's 1 away from the asymptote, and it's on the x-axis.
Is it always 1 away from the asymptote?
Today it will be,
Okay.
and probably for the rest of the chapter. It gets really tricky when it's not.
Okay.
Right? Are we okay with this? Right? So that's my problem. Here's yours. I want you to graph y is equal to log base 2 of x plus 4 minus 3. All right. So we have the asymptote is -4. The special point's 1 away. What's the -3 tell us to do? Are we okay? It tells us to take our special point and move down 3. So we've got the asymptote, we've got our special point. Do we have enough information to draw a picture? Yeah, we just put our pencil on the asymptote, hang with the asymptote, hit the point, and curve to the right. And does it look like we've taken our original graph and we moved it back 4 and down 3? Yes.
Is the special point always going to be the right of the asymptote?
What?
Is the special point always going to be the right of the asymptote?
Good question. I'll answer that later. All right. Sometimes.
How is it supposed to be left 4, right?
I'll get there.
Okay.
Okay. So wait, does this make sense? Yes.
It's bigger than that.
Yep. So does this part make sense? Again, nothing. I mean, the rules haven't changed. Inside moves left and right. Outside moves up and down. All right. Well, what if I gave you y is equal to negative log base 2x? What does that negative do?
On the left side?
Is the negative inside or outside? Outside. If a negative on the outside, what's it going to do to the graph? Flip up and down, right? Okay, everything outside impacts up and down. Everything inside does left and right. That's a negative on the outside, so it flips up and down, right? So I've got some crazy questions. If I flip up and down, does the asymptote change? Okay. If I flip up and down, does the special point change? Right? Flips don't change. If I flip up and down, that point still stays the same spot, doesn't it? The asymptote doesn't move. There's nothing in there to change the asymptote. The special point doesn't move, right? So what changes is instead of starting down and doing this, guess where we're starting? We start at the top, okay? So we start at the top, and when I start at the top, I'm going to go down, hit the special point, and go to the right. And does this look like our graph has been flipped? Does that make sense? All right? So we've got this, right? I mean, the rules haven't changed, right? A negative on the a negatives flip, a negative on the outside flips up and down. All right? So what if I gave you, let's give you y is equal to negative log base 2 of x minus 2 minus 3. So graph this. Okay, so let's see how this works. All right, where's the asymptote? 2. Is that easy? All right. The asymptote's sitting at 2, so here's our asymptote. Okay, special point's 1 away. What do I do with the special point? I go down 3. 1, 2, 3. There, okay, there's the asymptote, there's the special point. Now when I draw this, am I going to draw from the bottom or draw from the top? Why am I drawing from the top? Because there's a negative there. So I put my pencil on the asymptote, hang with the asymptote a little bit, hit here, and then curve that way. All right, everybody okay? All right, next up, I've got what if I give you y is equal to log base 2 of negative x? So, what does that tell you? Well, what's a negative next to the x tell you to do? Is it, or can we agree the negative's on the inside? Right? So if the negative's on the inside, I should probably put it in parentheses, right? So the negative's on the inside, that means we're going to flip left and right, right? And so now what happens? Did our asymptote move any? No, because look, what makes that 0 is still 0, so the asymptote's still sitting at 0, right? But now what happens is instead of the special point being to the right, guess where a special point is now? It's to the left because we flipped it. And so our special point's to the left. And now when we graph this, we put our pencil on the asymptote, hang with the asymptote, hit the special point, and then turn this way. And does it look like the black is the reflection of the red? So the good news is we just hit all of our things. But so now your turn. I want you to graph. Let's do y is equal to log base 2 of 3 minus x plus 2.
That reflecting graph that we just did, that was for log 2 minus x, right?
Yes. Yeah, this was, oh, I should have left that up there. This was for log base 2 of negative x. All right. So here, I'll pick up my blue pen. I'll ask some questions. Where's the asymptote? What makes this 0? Does everybody see what value of x makes this 0 is 3? Whatever makes this 0 is where your asymptote is. All right? Don't think about like whatever random rule you've got. The real reason is whatever makes this 0 is what gives you your asymptote. So we've got an asymptote at 3. Is the special point to the right or the left? How do I know it's to the left? Because there's a negative x. Everybody okay? We got a negative x, that means we got a special point to the left. What's the plus 2 tell me to do? Go up 2. Is everybody okay? We got our asymptote, we got our special point. Now the final thing we have to do is determine, do we start down at the bottom or start at the top? Start at the bottom, because it hasn't been flipped. So if we start at the bottom, we hang with the asymptote till we get our special point, then we turn to the left and we're done. Does everybody see how that works? All right. So I've got some good news and bad news. The good news is this is how I teach how to graph logarithmic functions. Right? I honestly think the shape of it is the most important part, and everything you need to graph any logarithmic function basically is what's the asymptote, where's the special point, all right? Do I swoop from the bottom or swoop from the top, and we're done. That's normally what I'm usually good with that. right? And it doesn't matter what the base is. Like if I were giving this test and it was like a paper and pencil, it wouldn't matter if it was log base 3, log base 4, log base 2, whatever. Everybody's going to give me basically the same picture. All right? But you're going to be doing this on ALEKS, right? And ALEKS is going to require more than just, they are going to require the asymptote, they are going to require they're going to require the special point, but they're also going to require another point, right? And actually, the homework assignment I'm giving you today is out of Khan Academy, and just the asymptote and the special point isn't good enough. You need another point. And so what I'm going to do is talk about how on earth do you find that other point, all right? And that's also going to translate to when I give you a question in ALEKS. Now, there's a complicated way of doing it. What I'm actually going to show you is what I think is the least amount of writing you have to do. But all of it hinges on two major facts. I want to make sure we understand these two major facts. If I give you log base 3 of 1, what's that? What's log base 3 of 1? 0. Log base anything of 1 is 0. And what's log base 3 of 3? Anytime these are the same, we get a 1. All right? Now, believe it or not, this fact has to do with your special point, and this fact has to do with finding the additional point. All right? Now I'm going to talk about what that means. So does everybody understand that we know log base anything of 1 is 0? And log base, anytime these are the same, we get 1? And this fact is huge. All right, so let's say I give you y is equal to log base 3 of x minus 2 plus 4. Notice I changed it. I made it log base 3. All right? Now, we know how to get the basic shape of this. Where's the asymptote? Everybody okay? The asymptote's at 2? That's easy, isn't it? Is the special point to the left or the right? To the right. And what's the plus 4 tell me to do? Go up 4, 2, 3, 4, right? And if this were just me, you'd draw this graph, wouldn't you? Everybody say that's what we'd get. We start here, hit this point, and curve off. Now, unfortunately, that's not good enough for Khan Academy and not good enough for ALEKS, so we need to practice. How do you get another point? And here's how you do this. My claim is, you know, do we know what log base 3 of 3 is? Actually, write it below. It's getting crowded up there. Do we know what log base 3 of 3 is? If I gave you log base 3 of 3 of plus 4, what's that number going to give you? 5. Are we okay? This is a 1, and then that's, right? Does everybody agree that this equals 5? And we have to plot another point. Here's how we plot that other point. I'm going to make an XY chart, right? And can we agree that if inside the parentheses is a 3, we know if what's inside the parentheses is a 3, then this whole thing's going to equal 5? What value of x needs to go here so that this is a 3? Can everybody see if x is a 5, that gives me the 3 I want? So if x is a 5, I get my y value of 5. Probably should have thought that out. I didn't want to have 5 and 5. This 5 is the y value. This 5 is the x value. We'll do another one. But what we end up with is at 5, we have 5. We have our second point. And now ALEKS can draw this. And now Khan Academy can draw this. let me try this again, and hopefully I pick better numbers than this. All right, where's the asymptote? Everybody care asymptote's at -3? Is that easy? So the asymptote's at -3, okay. Special point's 1 to the right, all right? What's the -1 tell me to do? Go down 1. Is everybody okay with that? Now, what value do I know? What would I like to be in the parentheses? 4. All right? And if I do that, what do I get? Okay, that's going to give me a 0. So my y value is 0. All right? If I want what's in the parentheses to be 4, what has to go in for x? So I see a 1 has to go in for x, because then that gives me the 1 plus 3 gives me the 4. And so what you just told me is when you plug in 1, you get 0.
This is not case 4 forms.
What?
Like, so when you got 0, so how did you get 0?
How did I get 0? Because when I plug this in, the original equation is this thing minus 1.
Oh.
So when you compute log base 4, this part's 1, right?
Mm-hmm.
But then you get this,
Okay.
right?
Thank you.
And so we end up with this. Does that make sense? And actually, I messed up. This isn't the question I wanted to have. The question I wanted to ask was, what's the graph of this? Now, to be honest, that 2 doesn't change. This doesn't change where the special point is. It doesn't change where the asymptote is. All it does is it changes your graph. It bends it a little bit, right? And what ends up happening here, if I had remembered that I wanted a 2 here, do you see that's a 1 times 2, so that's 2 minus 1? So we get a 1 there. And so now this would be the point. And so now it would bend it, it would make it look like that. All right, so here's what I want you to do.